everyone, let's do this problem. It says draw the appropriate condensed structure of a hydrocarbon that contains part 1, 2 carbons with sp³ hybridization, part 2, 2 carbons with sp³ hybridization and 2 carbons with sp² hybridization, part 3, 3 carbons with sp³ hybridization and 2 carbons with sp hybridization. So we're looking at the different types of hybridization, and we basically have to know how many bonds are going to be bonded to that type of carbon with a certain type of hybridization, right? Because if we want to determine the appropriate condensed structure, we need to know how many hydrogens each carbon should have. So looking at the different types of hybridization, we know that sp³ hybridized atoms have 4 charge centers. sp² hybridized atoms have 3 charge centers. And sp atoms have 2 charge centers. So remember, we're adding up the exponents to get the total number of charge centers, right? 3 plus 1 is 4, 2 plus 1 is 3, 1 plus 1 is 2. Now, what is a charge center? Let's curly bracket this. A charge center is going to include a lone pair or any type of bond. So 1 lone pair on an atom, 1 charge center. 1 single bond is 1 charge center. 1 double bond is still 1 charge center, okay? So it doesn't matter whether it's a single, double, or triple bond, that still just makes it 1 charge center. So the steps for this problem, like we said, we need to know how many atoms are bonded to each type of carbon. So it's going to be easiest if we first draw the Lewis structure for each compound. And then we'll get the condensed formula from that. Okay, so let's draw our first compound, which is 2 carbons. We'll write 2 carbons with sp³ hybridization. So sp³ hybridization means that those carbons should have 4 charge centers. All right, well, they're bonded to each other, so that means they each need 3 more bonds, so we can simply add 3 more hydrogens onto each carbon. So putting it in the condensed formula, we have 2 carbons, each with 3 hydrogens. So we list CH3, CH3. And that is the condensed formula for compound 1. Not so bad, right? All right, compound 2 is 2 carbons with sp³ hybridization and 2 carbons with sp² hybridization. So we have 4 carbons. Let's connect our 4 carbons. 1, 2, 3, 4. And it said 2 with sp³ hybridization and 2 carbons with sp² hybridization. So sp² hybridization means we're going to have a double bond, right? 2 carbons with sp² hybridization means we'll have 1 double bond between 2 carbons. So let's make that the center 2 carbons, why not? And then the outside carbons on the ends will be sp³ hybridized. So adding our hydrogens, the end carbons will have 4 single bonds, 3 CH bonds and 1 CC bond. And then our inner 2 carbons will have 1 single CC bond, 1 double CC bond, and 1 hydrogen CH bond, right? CH bond on each carbon. So for our condensed formula, we have 4 carbons. From left to right, we have CH3, CH double bonded to CH, so we write out that double bond, and CH3. All right, last compound. We have 3 carbons with sp³ hybridization and 2 carbons with sp hybridization. So we have 5 carbons and 2 carbons have sp hybridization, so I know that's going to be a triple bond, right? 2 carbons with sp hybridization will be 1 triple bond. So there are multiple structures we can do for this, right? Let's just make our triple bond the end between the between the first and second carbon. And then the rest will be single bonds. So with that information, we can add our hydrogens. Our 5th carbon will get 3 hydrogens. 4th carbon will get 2 hydrogens. 3rd carbon will get 2 hydrogens. 2nd carbon already has full octet with these 2 charge centers. And our 1st carbon will get 1 hydrogen. Our condensed formula will be, reading from left to right, we have our main carbon chain of 5 carbons. So CH3, CH2, CH2, C triple bond, CH. So those are the condensed formulas for these hydrocarbons, which makes A the correct answer for this problem. That's it for this one. I hope this video was helpful, and thanks for watching.